What is up, lovely people from the internet? Welcome to a new VR tutorial. So today I've got something exciting to show you. Obviously, you already know that we can use the input button on the controller to trigger a behavior in VR, but the main thing that changed these things to traditional controller, for example, is that these are tracked in space. And so in this video, I'm actually going to show you how we can use the movement of these controllers to trigger any input that we want by making our own gesture recognizer. So without further ado, let's get started. Okay, so as you can see, I'm in an empty Unity project right now. So I've already made the VR setup that I traditionally make, you know, with a big plane over there, with an XR rig that I've set up with here the left hand controller and the right hand controller. And if you don't know how to make this for yourself, you can watch the first episode of my tutorial series on how to make a VR game that I will put above just right there. Okay, so let's keep moving and make our gesture recognizer right now. So the first thing that I'm going to do is download the algorithm that I will be using to recognize the movement. So basically this is a really complex problem and there are multiple types of solution. The solution that we will see here in this video is a P recognizer. So I will put the GitHub link where you will have all the information that you want to know about this algorithm. But without further ado, let's first download it. So for this, we can go to the asset store over there, which you can access by going to Windows, Asset Store here. Then I will search here for P recognizer like this and press on enter to search this. And as you can see, we have one free asset popping on here, Point Club Gesture Recognizer, and this is what we will be using for our project. So I've already downloaded, so I just need here in my case to click on import to import it in my project. And finally, I will click again here on this import button. And there you go. So the package is now in our project. So let me go back to the scene tab. And as you can see, it is right over there in our project folder. And we can actually go into the example scene from this package by clicking on the $P folder here, then on scene, and now double click on demo. And so as you can see, this is just an empty scene with only one main camera with the demo script attached to it. So I'm going to just move the game window over there a bit higher so that we can play more easily our game. So if we click on play to test this demo, as you can see, it is not working at this moment, and we have here this error showing. You are trying to read input using the Unity engine.input class, but you have switch active, blah 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 blah. And it's because we are using the old input system, and the Unity XR Toolkit made us forced to download the new one. So to fix this issue, we actually need to go to Edit, Project Settings, then on Player, and here in Other Settings we can go up right there to Active Input Handlings, and instead of Input System Package New or even Input Manager, so the old or the new system, we can click on both and then click on Apply. Okay, so here we go, we can close this windows, and now finally if we click on Play, as you can see, I have no more error, but we have a little issues, and the issue is actually causing because we are using a VR headset and the main camera does not want this. So to fix this, we can leave play mode, and instead of setting the target eye to both, we can set it to none, main display, and this way the camera will not be using the VR headset. And so now if we click on play, even if we move the VR headset, it will not move the camera. And so we can now use the demo scene to know how our algorithm works. So on the left side, as you can see, we can draw a sign. For example, I can draw this X arrow, and I can either try to recognize the sign or add this as a new sign. But so for example, here, if I click on recognize, as you can see, it recognizes this as a 5-point star with a 0.67 precision value. So instead, I'm going to add this as an X. And if I click on add, now we have added this, this new gesture. And so, for example, if I try to redraw it, and click on recognize, now it recognizes this as an X with a 0.89 precision value. And there you go. So that's basically it. That's the whole algorithm for you. But we have some interesting things to see from this example. As you can see, this example allows multiple strokes. So I can do 1 stroke, 2 stroke, 3 stroke, and try to recognize this afterwards. And something else that we can notice is that the order of the stroke are not important here. So for example, here, this is an X, but so if I try to redraw it in another way, like this, for example, it will still recognize this as an X. So here, what's important to notice is that this algorithm works with multiple strokes, but also doesn't care about the movement, it cares about the result, which can be really interesting because your player doesn't have exactly the same identical gesture to make something. But nevertheless, the algorithm will always only take into account the final result. There are also other things that are interesting with this algorithm. Is that, for example, the scale. The scale is not important, but obviously the rotation is. So, for example, if I do this and that I set it to left triangle and click on add, if I try to do the same, so rotated to rotated, so a right triangle, it will not find this, and actually it's finding this as a D. And so here we can see that the rotation is actually important. And basically that's it. We have reversed engineers a bit how the algorithm works. Obviously, if you want to know a bit more about all of this information and characteristics about this algorithm, I will leave the full GitHub page where you will learn a bit more about the behavior of the P recognizer. But now for us, the main question is how can we use this in VR? And this is what I'm going to show you. And as you already imagine, the big challenge will be to make this thing works in 3D, because as you can see, this algorithm only works on a 2D surface, but in VR, the player is moving in 3 dimensions. So let me show you how to make this. So let's first leave play mode. I will then go to the sample scene here in the scene folder and double click on this sample scene. Okay, so we are back in the sample scene with the XR rig that we made. So now the next thing that I'm going to do is create an empty game object that I can call movement recognizer. So we can recenter its position, and I'm going to add a new script which will be called movement recognizer also. Perfect, we can double click on this script to open it. Now first in this script, I want to listen to the movement of the player after he press on a particular button on his controller. And for this, we'll need to add at the top here using Unity Engine.xr. And then I'm going to add 2 variables, a public XR node, which I will call input source. Then we will need the button that we want to press to trigger the movement. So for this, I will add a public input helpers.button called input button. And finally, I forgot to tell you, but we will need a float value, which will be the input threshold, and which I will set at the start to 0.1. And there you go. Now with this, we can check if the player is pressing on a button by doing this with input helpers dot is pressed. And then as you can see, we need an input device. So I will do input devices with an S, get device at XR node, so the first one, and then give it our input sources variable that we made. So the second parameter is the input buttons. That the third parameter is the Boolean value that will say if the input is pressed or not. So out bool is pressed. And finally, the third parameters is the input threshold. So input threshold. And there you go. So with only this line of code, we are able to get here this is pressed boolean value to know if the player is pressing on the input button from the input source. So now to trigger the start and the end of the movement, I will create a new new variable, which will be private of type bool and which will be called is moving, that we can set at start to false. Perfect. And now using this is moving boolean, we'll be able to know when we start and whether we end our movement. So for example, if we are not moving and that is pressed is true, so this means that we are pressing the button, this means that we start the movement. Now another case is if here we are moving, but that we are not pressing the button anymore, it means that we are now ending the movement. And finally, and in the case that we are moving and that we are pressing the button, it means that we are in the middle of the movement, so we are updating the movement. And there you go. Now I can create 3 functions for these 3 purposes. So a function called start movement, another one called end movement, and finally the last one, you guessed it, update movement. There you go, and we can put them each in their if statement. So start movement, end movement, and update movement. Already in the start movement, we can set the is moving boolean to true. And in the end movement, we can set the is moving to false. Okay, so already we can test this by writing something in the input console. So at the start of the game, at the start of the movement, I will trigger debug.start movement. So this will just write in the console window start movement. I can do the same for end movement. So end movement like this. And in the update movement function, we can write in the console update movement. And there you go. Now let's save our script and go back to Unity. As you can see, we have here on 3 input variable that we can set. So in my case, I think that I will set the input source to be the right hand. And for the input button, I want it to be the trigger button. And I think that I will leave the input threshold to 0.1. And now if I click here on maximize on play to maximize the windows and finally on the play button, as you can see, I'm able to play my game. And if I take my right controller and that I press on the trigger button, it updates the movement. And let's see if it did correctly call the start and the end function. So let's leave play mode. And there you go. As you can see, it worked. First, we have the start movement function called. And then we have the update movement that is called each frame of the game while we are updating the movement. And finally, the end movement is called just once at the end of it. Okay, so next step is to actually do something with this. So let's go back to our script. Okay, so now to have a movement, we need to retain all of the position that the controller will make when we are moving. Okay, so to retain all of the position from the movement, I can add a new variable, which will be private, and which will be of type list vector3. So it will be a list of position that I can call position list with an S, and which I can set initially to new list of vector3 like this. And now I will also add here above a public transform, which I will call movement source. This will be the source of the position which we will add in our list over there, so the position list. And so using these two variables, I can do here in the update movement function, position list dot add, and we can add here our movement source dot position. And there you go. This way our position list will add this new movement. Now, another thing that we want to do is to reset this list when we start the movement. So here in the start movement function, I will simply do position list dot clear. Perfect. And this will, as you guessed, clear the position list and will empty it completely so that it will not retain the movement of a previous movement. Okay, so at this moment, we are retaining every position that we will have when we are moving, which might not be a real optimized method for our algorithm because it will have too many positions to retain. And so another thing that we can do here is to only add this position if the distance between the last position and the new one exceed a threshold value. And this is what we will do now. So I will add a new public float variable, which will be new position threshold distance, and which we can set to 5 centimeters maybe. And now here in the update movement function, before adding the movement, I want to get the last position with position list dot count -1. So this will always give us the last element. And finally, if the vector 3, the distance between the current position, so movement source.position, and the last position exceed our threshold value, which is new position threshold distance, then in this case, we can add here this new movement source position. And one last thing that I want to do here is to make sure that we have at least one point in our position list over there when we are starting the movement. So to do this, we can simply here in the start movement, add the first movement. So I will simply copy here this line and put it over there in the start movement function. And this way, when we are starting the movement, we are adding as the first point the current position of our movement source. Okay, so our script is starting to take shape, I think. And so now we just need to find a way to test it. So here we have multiple methods to show the movement. If you are interested, I've already made a tutorial on how to make a tilt brush replica in my Patreon, and which show how to use a line renderer to show the movement on the controller that let us paint. So if you are interested to learn how to do this, you can support me on Patreon and you will have access to this exclusive tutorial. But in our case right now, if you are not interested, we will do something much simpler than this. We'll just display a cube when we are adding the points to the list. So for this, I will add here a new public variable, which will be a game object and which I will name debug cube prefab, like this. And so when we are adding a position, so over there in the start movement, I will do instantiate debug cube prefab and instantiate it at the movement source position. And we can give it a rotation of quaternion.identity. Perfect. So before calling this, make sure that we have a debug cube prefab. So if debug cube prefab. So by checking here this first, if you don't want to show the movement with a cube, you can simply don't give anything to this variable and it will simply ignore it and not spawn it. And finally, one more thing with this cube is that we don't want it to be shown all the time. So we want it to disappear after some seconds. So to do so, we can simply destroy it after maybe 3 seconds. So we can just write destroy at the in front here, and give at the last parameters something like 3 for destroying this game object after 3 seconds. So here to sum things up, if we have a debug cube prefab in our parameters, we instantiate it at the movement source position, and after that we destroy it after 3 seconds. And so now what's left for us to do is to copy this 2 line of code and put it where we are also adding the movement source here in the update movement function. So I will just paste it over there. And so there you go. So this way we are always showing when we are adding a new movement source. So let's go back to Unity. Okay, so here you go. So now what's left for us to do is to set the movement recognizer parameters. So for the movement source, I will go in our XR rig, and I will drag the right hand controller transform value here. So finally, for the debug cube prefab, I can right click in the hierarchy, go to 3D object, cube, and as you can see, this spawned a cube over there. So in my case, I will scale it to 0.05 centimeters, maybe. So this way, I think it will do good. We can even remove the box collider as we don't want it to collide with anything. And I can rename this game object debug cube prefab. Perfect. And now we can drag it in the project windows to make this into a prefab. And as you can see now, it is stored in our project folder. And now we can remove this one. And we can finally go back to our movement recognizer script and drag here our debug cube prefab in the debug cube prefab slot of our script. And there you go. Now I think that everything is ready. We can click on play to test our game. Okay, so I'm in VR right now. As you can see, I can see my hand. And if I press on the trigger button, as you can see, it correctly spawned a cube, and the cube destroyed after X seconds. And this way we are able to see the movement of our hand. And I don't know what you think, but I think it's working already really great. And you can actually do this for all the type of project, like I've shown in my tilt brush tutorial. You can use this system to draw, for example, or to show anything that you want, and to make something follow your controller. But in our case, we will use all of this list of points to create a movement that we will be able to recognize with our gesture recognizer algorithm.